Examples. Example 1. So given 2x power 3 minus 5x squared minus 4x plus 12 is equal to T of x factorize T of x and solve T of x is equal to 0. Hence, sketch T of x indicating all intercepts. Solution. So the polynomial given is px is equal to 2x power 3 minus 5x squared minus 4x plus 12. Step 1, we look for a factor for any number that when you take rather x there will get 0. So you can use that number in a synthetic and have px factorized. The number that we go for are the factors of the constant and the factors of the coefficient of the highest degree. Now that the coefficient of the highest degree is also a factor of the constant, so we are safe going for the factors of the constant. Starting with 1, P of 1 is giving us 2 minus 5 minus 4 plus 12. For sure, this is not 0. P of negative 1 is giving us negative 2 minus 5 plus 4 plus 12. For sure, this is not 0. So we move to P of 2. We get 2, 3 minus 5, 2 squared minus 4 by 2 plus 12. So what do we get here? 2, 3 is 8. 8 by 2 is 16. Minus 2 squared is 4. 4 by 5 is 20. Minus 8 plus 12. This is giving us 16 plus 12 is 28. Minus 20 minus 8 is also 28, giving us 0. So we have found a factor 2. So since 2 is a factor, we can go to synthetic division, place 2 here, and go and collect the coefficients of the values, of the variable x. Starting the highest degree, we get 2. For x squared, negative 5. For x, negative 4. The constant, 12. And then drop this guy down, multiply 2 by 2. 2 by 2, we get 4. Add, we get negative 1. 2 by negative 1, we get negative 2. Add, we get negative 6. Get negative 12. Add, we get 0. That means that P of x is equal to x minus 2 multiplied by 2x squared minus x minus 6. Remember we said after you write this here, it means that the function coming inside here differs by 1 when it comes to the powers of the highest degree. That means that now we still have what to factorize. This piece here can be factorized further. So we need to factorize it. So x minus 2. Maybe we can do it from here. 2x squared minus x minus 6. The product is 2 by negative 6, which is negative 12. So we can use 4 and 3 to give us a 1. So we have 2 squared minus 4x plus 3x minus 6. So 2x is giving us x minus 2 plus 3 giving us x minus 2. So that when we come here, we'll have x minus 2 multiplied by 2x plus 3. We've answered the part that says factorize px. It is factorized. The next thing is to solve for px is equal to 0. When p of x is equal to 0, it implies that the factorized form is then equal to 0 because it is what is px. Now these guys are repeating, so if we pick 1, then we are safe, giving us 2. Even if you solve the other one, you get 2, and 2 is equal to itself. So you don't have to worry there. Is 0, giving us x is equal to negative 3 over 2. So we have found 2 values of x. And so we are ready to sketch. The only thing remaining is the y-intercept, which we said the y-intercept is just p of 0, giving us 12. So 0. So what is sketch here? Negative 3 over 2. This number is smaller than negative 1. We also have 2 here. The y-intercept is 12. Somewhere there. So now we need to sketch. If you look at the gap here, it looks like.
Sir.
Hello.
Just a minute. And didn't you make a mistake there? Isn't it supposed to be 3 open brackets x minus square? How
3
is x equal to negative 3 over 2? I'm getting the 3. This one is factorize.
This one here. Is it the one?
Yes.
So since we have the product to be 2 by negative 6, which is negative 12, the sum negative 1, the factors could be negative 4 and 3. So that when we have 2x squared minus 4x plus 3x minus 6, 2x becomes common, giving us x here minus 2 here. 3 becomes common, giving us x minus 2. And then have it collected in this form. And then 2x plus 3. I still get the same thing.
Okay, it's me. I made a mistake. I forgot the square.
Okay. So now, when we have those intercepts there, we're trying to see. Yesterday, we were easily using this gap here to tell that space should have the turning point. So let's see if that's the case even today. If you try negative 1, if we try negative 1, no, negative 1 is somewhere here. Sorry. Negative 1 is somewhere here. If we finish up this, it was giving us negative 7. plus plus 16. This number is less than 12, of course. But if you try this one, 1, it was also giving us 2, which is 14, minus 9. Smaller than even that other one. So what should we do? Let's try half. Though we know we're just trying to get a confirmation here, we try half. 2 multiplied by 1/8 minus 5 multiplied by 1/4 minus 4 1/2
So
plus 2. Hello.
on the trying part, how will I like choose the numbers that I'm supposed to be trying when I reach where you've reached?
So here the idea is we just want to see whether the curve will turn after the y-axis or before. So you can pick any number that lies on the right of the y-axis and any number before, except that in your picking, it's nice working with whole numbers. But if whole numbers cannot give you what you're looking for, that's when now you try to go for the fractions at your choice. So you can say 1/3, 1/4n.
So it doesn't matter if it's more than the numbers that I have or less.
No, it has to be in between the two numbers because that's where it's going to turn from.
That what, sir?
It has to be in between these intercepts here because that's where it's going to turn within these intercepts. So if you go for 3, there may be no use because once we know the curve orientation, then we easily know that this side it will be down or up. So I'm interested in the numbers that lies between the intercepts.
Okay, sir, thank you.
So here we have 1/4 minus 5/4 minus 2 plus 12/1. Let's just say 1/4 minus, okay, plus 10. Yes?
Here, what's that? I'm behind a bit. You are trying to get the turning point.
We're trying to estimate the turning point.
Also, it is to get any number on the x-axis, then you place in the actual equation. Then
Yes,
you find the value of y.
So initially, we know that it's supposed to be here. So we're doing this to confirm. But how we get them, we just look at the bigger space in between the intercepts. So now I'm just trying to confirm that thing which we used yesterday. So let's see if it will work here. So we get 1 as 4 to be down and get 1 minus 5 plus 40. This is giving us 41 minus 5. 41 minus 5/4. This is 36/4, giving us 9. Okay, so we are still getting a number below 12. So let's get back to this actual number so that we can know whether we are getting closer or we should widen it. So -7 plus 14 minus 9 is what is 14 minus 9? It's 5.
It's 5, sir.
All right. Okay, and then -7 plus 16, it's 9. So here we have 9, 9. Okay, so let's try to get -half. I want to see. It's like there's drama here. let's get negative half and test it throughout. So negative half will give us 2 negative 1/8 minus 5 1/4 plus 4/2 plus 12, giving us negative 1/4 minus 5/4 plus 2 plus 12, which is 14/1. Get 4 down, we'll get negative 1 minus 5 plus 14/4 plus 56. So we get 56 minus 6, we get 50/4. 50/4, 1, remainder 1, and 2, remainder 2, 12.5. The numbers 14 minus 9, these were coming from here when we are testing negative 1 and 1. Okay, so we have gotten 12.5, a number that is higher than that. So, meaning that we don't just have to assume. You don't just have to assume, so I have to be solving. So this means that it's turning from, though this interval here is smaller than the other, it contains the turning point. Okay, let's see. Now we get a number before. Let's use negative 2. Negative 2 will give us 2 negative 8 minus 5. 2 squared is 4 plus 8 plus 12. This is negative 16 minus 20.
So
Hello.
I'm now confused. Why is the negative 2 coming in? Like, why is it coming in?
Look, the power is 3, and yet we only have 2 intercepts. So this may mean that one of these intercepts is a turning point. That's what we're trying to check. So also check, if we find that this side there's nothing wrong, we'll go to, if we find that before this intercept here, we have a negative number, we'll go to 2 and check after 2. What happens?
So I'm not convinced.
Look, since we have 2 intercepts, how are we going to sketch our graph? Since it's supposed to have 2 turning points. So far, all we know is that it's going to turn after. So suppose we assume that it's going to look like this. Come down. So it's like avoiding too big. So come down to 2, meaning it's going to look like this. But it's a 3, it's a polynomial of degree 3. So we're not so sure if this is the shape or it must have 2 turning points because it's a polynomial. So before we assume or sketch this form, we must be sure that it only has 1 turning point by testing what happens before each turning point and after.
Yes, that's what I've understood.
So now, let's continue the testing. So here, we'll get plus 20, which is negative 16. Hello?
So You're saying that for the turning points here, we first have to pick between -3/2 and 2, right?
And 2, yes.
Any value,
Any value.
right?
So we've seen that for negative numbers less than -3/2, we are having negative numbers. Now let's see what happens after 2. Suppose we try 3. So P of 3 is going to be 2 by 27 minus 5 by 9 minus 4 by 3 is 12 plus 12. This is 54 minus 9 times 5 is 45. -12 plus 12 will cancel each other. So 54 minus 45. This is 9, a positive number. So meaning that 2 is a turning point. So our sketch will run this way, come back to 2. Maybe now I'll draw it nice. Just change the ink a bit. So it will come from here, hit here, go up, and come down here. So this is P of X. So we have more work when we discover that the polynomial has only 2 zeros and yet is to the power 3. Hello?
Sir.
Hello? So how is 2 our turning point? Because before you get to 2, you have positive numbers. After 2, you still have positive numbers. So it means that you cannot go beyond 0 from 2. All the y's are positive. That's how we know that 2 is a turning point.
Sir,
Hello?
can you please kindly just go through how you sketched?
Okay. So the sketching part depends on this thing that we've been doing here. On this thing here. After finding 2 intercepts, you find 2, you also find -3/2. You place them there, you place them there. The question is, the polynomial we have is to the degree 3. So does it mean it only has one turning point? Those are special polynomials. So we need to be sure that it only has one turning point and not a 2. So we go and check. So before, we need to be sure where it's turning from. Is it before the y-intercept or after the y-intercept? Okay. Okay, I'm going through again. We are saying after having 2 intercepts for x, then notice that there's a problem here. I need to be careful in sketching this thing. First thing I need to know whether it's turning from y, before y or after y. Right? Then you check, you get numbers after 0, meaning on the positive x side, before 2. So we tried half. Half gave us 9. We went to the other side, we got -1. -1 gave us 9. So we discovered that in the wider perspective of the left side, we could get 9 at a far point from 0. So we tried a point closer to 0, but on the left, which is -half. And -half gave us 12.5. 12.5 is bigger than 12. That's just telling us that the graph is beyond 12 on the left. So since 12 is our intercept, it must be coming from above the 12. That's why it has gone beyond 12 on the left, coming down. Now you go and check on the issue of turning points. How many turning points should we have? So you go to 3/2, -3/2. We've already checked that after -3/2, the values you are getting of y are positives, meaning it will be above the x-axis. Then you go and check before the -3/2. So I've gotten a number smaller than -3/2, which is -2, tested, and it gave us a negative number, meaning that this whole interval, the numbers will be coming from down. The graph will come from down because they are negatives. So you know the issue is not with -3/2. We go to 2. Now we checked half. Half gave us a +9. So because half gave us a +9, it means that in between 3/2 to 2, we have positive y values. Now let's see what happens after 2. Now after 2, we got 3, and 3 gave us what? 3 gave us 9. 9 is positive, meaning you have to go back to the positive, meaning you want to go beyond the x-axis when you reach 2. Blessings.
Sir,
Yes.
as x approaches 0, all the values of y are not surpassing 12. Why did you turn the curve above 12?
As x approaches 0 from this direction, at -half. At -half. What did we get? We got 4. Not fine thing. No, 4 and 4 goes 10 times. And into 44, it goes 2 times. I mean, in times. Into 48, 4 times. Then you still have 2. So that is 4 times 2, which is bigger than 12. So the importance of testing is